Hello everyone. My name is Zach Payne, and today I'll be presenting to you about Arvo and Fratres, the use of his compositional tintinnabuli technique. So, who is Arvo Päre? Well, Arvo Päre is a modern 20th and 21st century minimalist composer. He was born in 1935 in Payne, Estonia. And he created minimalist music primarily through the first half of his career. Now, people who know things about people who know things about minimalist music try to place him in the category as American minimalist music, but that's not really accurate because Päre is kind of in his own unique category of minimalism because he created his own technique, tintinnabuli. Now, what is tintinnabuli? Well, there's two answers to that question. There's the technical answer, and there's the answer Päre gives every time you ask him what is tintinnabuli. And obviously the answer he gives every single time is slightly different and meaning something slightly different every single time. So these are some snippets from some of his quotes, trying to get the basic gist of what he's trying to tell you what it is. So basically, what he says is when the complex and multifaceted of life is too great, he likes to retreat to a simple perfection known as tintinnabuli. When he's in the presence of this, all other things fall away. And this perfection comes in the form of many guises, according to him. And he says that this perfection is like a musical triad or a simple chord, where the three notes are like bells. Hence the name in his language, tintinnabuli. And also, Carla, if you can click on the gray square right there, it is like wind chimes. That's good, yeah. All right. So what does this mean in actual music terms? Well, it is if you're writing minimalist music, where you choose a single triad. Once you choose the triad, you basically then have two voices you can use in tintinnabuli. There's occasionally an optional third voice. The two main voices are the melodic line and the bass line. The melodic line is a monophonic voice, which means it's a single melody, no multiple melodies interacting, just one melody. And it usually works in a stepwise motion, never making a lot of jumps or leaps. The tintinnabuli bass line is basically using only the three notes from the chosen triad. It could be above or below the melodic line, but it is always constrained to those notes. The occasionally used third voice is a held fifth, which is sometimes called the power chord, down in the very lower registers, like ancient Gregorian chant. Both of these voices can be doubled, and multiple cells of tintinnabuli can exist within the same piece. All right, so here is what it looks like on a very basic level. The black notes is a simple A minor scale in a and that will act as the melody. And as you can see, the white whole notes are basically acting as the tintinnabuli bass line. And you can have it above, as you can say, above, close to the melody, above a good raised fifth above the melody, and also below, closely, and below a whole raised fifth below the melody. And as you can see, it's very much is a blocky sort of bass line to accompany your piece. Your melody, as it were. Right. So now that we know what tintinnabuli is, we'll move on to the piece that uses it, that we're going to be looking at today, Fratres. So Fratres was one of Päre's pieces he created in 1978 as a general melody, meaning it wasn't made for any specific instrumentation in mind, but later he adapted it for many different types of instruments to use. The version we're looking at is for violin and piano. Now, obviously, Fratres is an example of a minimalist piece with tintinnabuli inside of it, but also it has two major themes that it uses to interact with this compositional technique: mirrored symmetry and structured patterns. To go into mirrored symmetry, I'm going to show you some examples that the piece has within itself of these themes. Now, first, harder to find one is if you line up all the pieces, the notes that the piece uses, from the main pitch, C sharp to C sharp, and you measure the distances, semitone, whole tone, or one step, two step, one step, two steps, at the center note in this arrangement, the distances are mirrored. Another overall mirrored symmetry example in the piece is that the piece has an overall arc that is mirrored in the center. And this basically is an arc of intensity. Now, the first bit of intensity that it has is volumetric. Each piece starts with increasing volumes until the middle piece where it dies down a little bit before going back up to intensity and descending down to the last variation at the ninth movement, or ninth variation rather. Let's see, and the intensity going up is intensity by pitches per beat. So obviously it starts off using triplets, goes to eighth notes, goes to 16ths and 32nd notes for the fourth variation there at the height of intensity. Then we have the mirrored movement in the fifth variation. The sixth variation is also the most intense variation, except in intensity of chord dissonance. And obviously the piece gets more and more constant as you descend down to the ninth variation. The final example of symmetry is baked into the second theme of the piece, structured patterns. Now this theme is a constant yet subtle constant within the piece. And basically the melody of the piece takes the shape of the root of these four notes on the screen right here. Now the melody basically uses this root and expands it and then mirrors it in a formula, in a very structural formula, by the way, as in it is so set that you can produce it with computer code. Now, since I'm also a computer scientist besides a musician, I went ahead and did so. And in order to do that, I'll explain myself later about it, but I'll take you into some of the basics to understand what I'm getting at and why this works, and so you can understand a little bit what you're looking at. So some very basics of computer code. You have basically computers are entities that make no initiative. They take one command at a time, usually, and then they work through it. You have to use very basic command statements to get them to do things, and also to make decisions. For example, if, else, for, while, and do, to name a few. A basic example is if condition X, do this task, else, do other task. Let's see. But also you can accomplish more complex tasks with loops. Now, these are three basic examples of loops, and to get the basic idea, a while loop, basically while you have a condition X, you loop the code within the while loop. A do while loop basically is you loop the code while condition X. Basically, you are checking the condition on the top with a while loop, and at the end of the loop with a do while loop. And then finally a for loop, which is basically a timed loop, where you can use the values you set up to time the loop in your own loop. So let's see. Now that looks like when you take a variation of the piece and you put it into computer code, it looks like this. Now I'm not expecting you guys to understand what you're looking at, but I kind of want to show a few basic. I kind of want to show the basic idea of it, in the sense that the entire structure is a do while loop that repeats twice, and then basically then you have a for loop for each mirrored half of the piece. And the for loop then uses two while loops to basically expand upon the values that you're giving it. So what this looks like in non-computer code, like why do this, is to show that you can't do this with a lot of pieces. This is actually a very interesting that Fratres can be displayed in such a set and unwavering manner, and yet it's so subtle within the piece. It looks like the general shape the melody takes when you follow this formula looks sort of like this curve. Now, to demonstrate the curve, I'm going to quickly play it out on the violin. And I want you to keep in mind that at the center line there, that is the mirror point. We're going to repeat it up to 3 times to make Fratres' melody. So if you'll follow along, maybe you'll get what I'm trying to get at here. So basically what I did was I set the condition or the amount of times to loop as 3, which is what Fratres does. And then basically I followed this, where every single time repeated, I added 1 to the amount going down and descending back to the home pitch. And then mirrored that whole thing for the second half of the melody. All right. So how do these two things interact? How does tintinnabuli and this formula interact finally to make Fratres? So basically, the formula is basically the melodic line that Fratres uses, while the tintinnabuli bass line is constantly being played and shared by both the piano and violin. In this example, you see the piano and violin both share the bass line in a superior and inferior positions above and below the main melody. And the piano is taking 2 instances of the melody a third apart. And basically, let's see. So always within the piece, there's going to be 2 instances of the melody and the bass line. And within the variations, this is a constant within the piece. Even when the variations get very complex, the tintinnabuli and formula are still there. For example, you see these notes here where the melody is being very complex in the middle of the movement. The notes ticked in red are basically the tintinnabuli bass line. In these groups, cells of 4/16 notes, half of them are each part of the bass line, while again the piano is taking over both sides of the melody. So with all that in mind, I hope as I play this piece to you, you can keep in mind this structure and formula within it, as well as the symmetry throughout the entire piece. And I hope that, let's see. I hope with this you can listen and try to pick out the subtle themes here that are going on. So without further ado, ladies and gentlemen, I give you Fratres for violin and piano by Arvo.
Thank you.